Hello, today I will introduce you to the GAZDA G105 thermostat. This device is designed for automatic temperature control in heating systems. It's very simple and functional. It has a single operating mode, heating mode. This means it can control various types of heaters and electric boilers. The G105 is mounted on a DIN rail and has a compact size of 2 modules. Now, I've connected it to the power supply and hooked up 2 light bulbs. The one on the left simulates the pump, and the one on the right represents our imaginary boiler. With this setup, I will demonstrate how the thermostat works. The thermostat display currently shows the temperature of 20.8 degrees Celsius. This is the temperature measured by the sensor included with the thermostat. The sensor's cable length is 1 meter, but it can be replaced with a longer one if needed for measurements in a different location. Now let's look at the thermostat's outputs. There are 2 outputs, one for controlling the pump and the other for controlling the boiler. These outputs can handle a maximum current of 5 amps, making it possible to connect the pump directly or control the boiler via a contactor. Let's see how to set the temperature on the thermostat. It's very straightforward. You need to set 2 parameters, the upper and lower temperature limits. The upper limit is the temperature at which the boiler will turn off, set using the right button. The lower limit is the temperature at which the boiler will turn back on, set using the left button. The adjustable range is from 5 degrees Celsius to 90 degrees Celsius. Now, I'll set the upper limit to 65 degrees Celsius and the lower limit to 60 degrees Celsius. Currently, the measured temperature is 20.8 degrees Celsius. Let's increase the temperature to 60 degrees Celsius. As soon as the temperature reaches 60 degrees, the pump will turn on immediately. Look, the left bulb lights up, indicating that the pump has started working. After a delay of 15 seconds, the boiler will also turn on. Look, the boiler is now on. This demonstrates how the thermostat first activates the pump, and then after a delay, turns on the boiler. This sequence ensures efficient and safe operation of the heating system. Now, let's see how the thermostat turns off the pump and boiler when the upper temperature limit is reached. The upper limit is set to 65 degrees Celsius. I'll continue increasing the temperature using a gas burner to heat the sensor. Once the temperature reaches 65 degrees Celsius, the boiler will turn off. However, the pump will continue to run for about 20 seconds. Look, the boiler has turned off, but the pump is still running. The pump will continue operating to distribute residual heat throughout the system, enhancing heating efficiency. Now the pump has also turned off. This feature is critical. The pump doesn't run continuously. Instead, it turns on before the boiler and shuts off after the boiler. This intermittent operation saves significant energy and makes the heating system more efficient. Currently, the system operates with a jumper installed. The pump and boiler are on, and the circuit is closed. This means the G105 thermostat is autonomously controlling the heating system. Now I'll remove the jumper. Watch closely, the circuit is broken, the boiler has turned off, and the pump will stop after 20 seconds, as explained earlier. This demonstrates that the thermostat is waiting for a signal from an external device, such as a room thermostat. Let's imagine that we've connected a room thermostat. To simulate this, I'll reattach the jumper to close the circuit. Look, the circuit is now closed again, the pump turns on first, and then the boiler follows. The bulbs light up, showing the system is working again. When the jumper is replaced with wires from a room thermostat, the G105 begins working in sequence. This means that the heating system is controlled not only by the G105, but also by the room thermostat. For example, if the room thermostat breaks the circuit when the room temperature reaches its set value, the entire heating system will stop, regardless of the temperature set on the G105. For instance, if the room thermostat is set to 22 degrees Celsius and the G105 is set with an upper limit of 80 degrees Celsius, the room thermostat will take precedence. If the room temperature is below 22 degrees Celsius, the circuit remains closed, and the G105 manages the heating. But once the room reaches 22 degrees Celsius, the thermostat breaks the circuit, stopping the pump and boiler. Or on the contrary, if the G105 is set, for example, to 40 degrees as the temperature of the heat carrier, it will most likely break the circuit much earlier upon reaching this temperature. Meanwhile, the room thermostat will remain closed, waiting for the air temperature to rise to 22 degrees. Simply put, the boiler and pump will stop working depending on which of the two thermostats breaks the circuit first. It is also important to note that the order of installation of thermostats in the circuit does not matter. Moreover, any number of additional thermostats can be connected in series to this circuit. The principle remains unchanged. Whichever thermostat breaks the circuit first will be the reason for shutting down the boiler and the pump. It's important to note that only devices without voltage can be connected to these contacts. These include battery-operated thermostats, bimetallic regulators, or devices with dry contacts. Such devices are safe to use with the G105 and are compatible with most heating systems. We've reviewed the operation of the G105 thermostat in detail. I demonstrated how to set the upper and lower temperature limits, how the device controls the pump and boiler, and how to integrate a room thermostat. This thermostat is user-friendly, versatile, and offers convenient heating system control while helping save energy. Thank you for watching. See you in the next video.